today is part 2 of section 4 in chapter 9, and we're going to continue to solve problems in factored form and also learn how to do word problems with a special vertical motion model. I know you're all very excited about this. Okay, so today we're just going to start off with a couple of examples, just building off of what we learned yesterday. Okay, so our first problem is going to be 6n squared equals 15n. Now, this poses a problem because if we want to factor something and use our zero product property, it has to be set equal to 0. So here we're going to start off with the initial step of subtracting 15n on both sides so that we can have it set equal to 0. Okay, now we cannot combine these two because they're not like terms, so you can't write negative 9n. Okay, we have to leave it as 6n squared minus 15n. They're not like terms because they have a different degree. Okay, so now that we're set equal to 0, now we can use our greatest common factor to solve. Okay, so 6n squared is 2 times 3 times n times n. 15 is 3 times 5 times n. So what do they share? They both share a 3 and an n. So we're going to pull out that 3n, and we have leftovers of 2n minus a 5 equals 0. Using our zero product property, we're going to have 3n equals 0 and 2n minus 5 equals 0. Okay, so when I solve, I'm going to divide by 3. My first root here, n equals 0. And then when I solve my second root, I want to use order of operations in reverse, so I'm going to add first, and that gives me 2n equals 5, and then I'm going to divide. So n equals 5 halves, or you can write it 2.5. Okay? So our solutions, our roots are 0 and 5 halves. Over here, we're going to have the same issue. So here we have 4x squared equals 2x. Okay, here we're not set equal to 0, so we first need to subtract the 2x on both sides. Again, we cannot combine these because they are not like terms, so we're going to have 4x squared minus 2x equals 0. From here, we're going to use greatest common factoring so that we can set up our zero product property. So 4x squared is 4 times 4 times, oops, excuse me, whoop, 2 times 2 times x, and 2x is 2 times x. So we share a 2x in both of them. So I'm going to factor out a 2x, and here I'm going to have a 2x left over. Here, I don't have anything left over. However, I cannot write 0. So I need a placeholder. So what I'm going to put is I'm going to put a 1 equals 0. That being said, because we're using greatest common factoring, if you were to go from here to here, we would use the distributive property. So when we're factoring, we're actually undoing the distributive property. So if the distributive property is multiplication, then undoing that would be division. So if we were to divide 2x by 2x, we would get 1, not 0. So that's why we need that 1 there. Okay? Now that I'm set up in my product, or my factored form, I can set my 2x equal to 0, and my 2x minus 1 equal to 0. So here when I solve, I divide by 2, and x equals 0. And here, I'm going to first add 1. So 2x equals 1, and then solve for x by dividing by 2. X equals 1 half. So our roots are 0 and 1 half. Okay, so same thing as yesterday, we just have to add that first step of setting it all equal to 0 initially. Okay? On to the word problems. Okay. In this section, we're going to be talking about a vertical motion model, and it's actually going to continue through the chapter, so don't forget this. The vertical motion model predicts the height of an object given time, initial velocity, and initial height. Okay, so if you're projecting something like something jumps, or I don't know, you're shooting something in the air, a rocket, something like that, I don't know. Let your brain run wild on what you're projecting. Okay, but here it has h equals negative 16t squared plus v times t plus s. Okay, here this is the height of the projectile. This is the height when you're done projecting it. Okay, both of these t's is going to be your time in seconds. Your height, by the way, is in feet. The initial velocity, the initial vertical velocity, is v, and that is in feet per second. And then s here, this is the initial height of the object. Okay, so this is initial height, this is your end height. This is your time, and this is your velocity. Okay? So we're going to use that to solve this problem. A startled armadillo jumps straight into the air with an initial velocity of 14 feet per second. About how many seconds does it take to land on the ground? Okay, so about how many seconds? That tells us what we're solving for, which that means in our problem we're going to be solving for t. Okay, we don't know what t is, we're going to be looking for that. Which means that the rest of the information is given to us in this problem. Okay, here we have an initial velocity of 14 feet per second. That is our v. Okay, so check, we have our v. Now we need to look for our initial height and our end height. A startled armadillo jumps straight into the air. Okay, if an armadillo is startled and he jumps, where is he jumping from? The ground. Okay, the initial height of the ground is what? 0. So here our s is going to equal 0. That's nice. Okay, how many seconds does it take to land on the ground? So what is his end height? His end height is also 0. That's a 0. Okay, so using all of this information, we are going to have 0 equals negative 16t squared plus 14t plus 0, which you don't need to really write the plus 0. Okay, so we have this. What does this look like? We're set equal to 0. We have two terms here. Why don't we use greatest common factoring to solve? Fantastic. Alright, so negative 16t is 4 times 4, which is 2 times 2 times 2 times 2, and t squared is t times t. 14t is 7 times 2 times t. What do they share? A 2 and a t. So I'm going to have 0 equals, I have this 2t that I'm going to pull out. Here I'm going to have a negative, don't lose that negative. 2 times 2 times 2 is 8t plus 7. Okay, so now I solve. So I'm going to have, I'm running out of room, I apologize. I'm going to have 2t equals 0 and negative 8t plus 7 equals 0. That's using my zero product property. Okay, so here if I divide by 2, t equals 0. Here to solve, I'm first going to subtract 7. So I get negative 8t equals negative 7. Then I divide by negative 8. And negative divided by negative is a positive. So I get positive 7/8. Okay, I have two answers. Real life situations require real life consideration. Haha. Okay? So if an armadillo, if an armadillo is jumping into the air and landing, and I'm solving for how many seconds does it take to land on the ground, which one of these is most feasible? Can this happen in 0 seconds? No. There's going to be some time elapsed between when he jumps and lands. So therefore 0 is not our answer, but our answer is going to be 7/8 seconds. Okay? That is our answer, and that is how you use the vertical motion model. Make sure that this gets into your notes because we will use it later on section.